I was acting.
Now you may be wondering, why the name? The Storm Chaser 9001? Well, that's because
it's over 9,000!
One of nature's courses is wildfires. Wildfires serve as a sort of cleansing of old and dead plants to allow the growth of new and healthier ones. In the past 10 years, the average number of hectares burned per year was 348,900. That's approximately 37.6 billion square feet. It's important to note, however, that in the span of 4 years, from 2016 to 2020, the average has been nearly twice that amount, at a stunning 651,500 hectares burned per year, which is approximately 70 billion square feet. The damages in the past 10 years have cost around 2.9 billion Canadian dollars. Since wildfires aren't going away anytime soon, we decided it would be much more worth the time to come up with a device that could help with somehow changing the impact of these fires.
Our device originally started much differently than it is now. Originally, it was planned that the device will be deployed by the hot shootings when clearing brush before the fire season, and it will deploy fire suppression or water, but after further research and interviewing, we found that wildfire only pose a true problem when near inhabited areas. Since forest fires are a natural occurrence, it will almost be wrong to intervene every time one occurs. Therefore, we found that it will be better to know when one is happening, rather than try to somehow stop it with insufficient resource.
For this year's final project, we decided to go with the issue of wildfires, specifically an item that would help detect and observe a fire, as well as act as a aftermath approval device. Our device is a small cylinder which contains a microchip that transmits the humidity, temperature, as well as sweat and UV indexes. Other than just being a detector, it has a spring-powered extension mechanism that will allow it to clear the surface of the ground and then spread seeds around it in an approximately 5-foot radius. The uses of this device are unlimited. However, our prototype was limited only to the coding, material, and manpower available. The device has a spike at the bottom of the cylinder, which will help drive the sensor approximately 4 to 6 inches into the ground. We went with a compact design that is mostly mechanical in order to reduce the likelihood of being affected by the high temperatures that it would need to withstand.
Hello everyone, this is our product called Fire Chaser 9001. So first we have a lid above the entire device. Since we will bury this device under the surface of the soil, it is used to prevent soil from entering our device. Also, we made a stake to make it easier to bury it in the soil. You can see that under the whole body. And under the cover is our extension mechanism. When we pull out the rod, the cone will be bounced by the spring, so the seeds we put on the surface of the cone will be evenly spread in the area around it. Below the cone, we will put the Arduino circuit board to check the temperature, humidity, and other information. Finally, under the whole device, we made a hole in order to connect the USB cable to the Arduino.
This is the brain of a device, the Arduino MKR1010 with Wi-Fi and the ENV shield by the same company. This circuit board allows our device to connect to a laptop and transmit data such as temperature and humidity, as well as other secondary data. Also, you can connect an SD card to the circuit board to store these data for use at a later date.
So just a quick side note before we play the video. Basically, we have it set up in a plastic container, and our device is up against the side of the container as to be able to be seen as simulating it being under the ground. And ultimately the final design would be further down in the ground, as well as have a much more powerful spring. But with problems of shipping, not available stock, we weren't able to find the spring stiffness that we needed. So we just went with a spring that'll give enough to show really how it would work.
Oh my god! Wow!
As this is our first prototype of a device, there are some limitations to it. For example, the prototype is made from 3D printed plastic, but the device would be made from heat-resistant metal. Another limitations that we are aware of is the transmission range. Currently, our device can only be connected via Wi-Fi, which therefore limits its range significantly. This is due to the electronics, and therefore we can improve upon it by using cellular data to send data that way. Another limitation is the functionality, with the extension mechanism not being automated, as we have to manually pull a lever for it to work. If in the future, we can improve upon this by integrating the extension mechanism with the electronics so it can be controlled automatically. And a final problem is the battery size. Due to the recent flooding in BC, we were not able to have our battery in time. Therefore, we must use a conventional battery pack used for phones. These battery packs are quite big and does not fit into our device.
For years, firefighting strategy have been adjusted and slightly improved, in order to be much safer than ever before. The one problem with a fire, however, is that it can often get too far out of control, and ultimately just wreak havoc on all of our methods of fighting them. Our device would serve as early warning system on the climate surrounding a possibility affect area, and be able to serve as more accurate estimate as to the true likeness of fire. For firefighters, it is sometimes difficult to identify a wildfire within a timely manner. Without the proper time to plan and prepare, the firefighters might not be able to coordinate an effective mission. Our device can alert firefighters when temperatures are too high and humidity is at a dangerous level in a certain area. This allows more times for the firefighters to plan and coordinate firefighting missions, hopefully reduce the chance of fire getting out of control. After forest fire, the new clear area allowed for new trees to grow. Well, in most cases, this process is natural. Our devices allow people to quickly intervene and plant new seeds. To do this, firefighters can preload our fire sensors with seeds suitable for its region before deploying them to the forest.
The purpose of this device is not to make a profit, but rather lessen the impact of wildfires on the wilderness and around populated areas, and to give information on the weather and temperatures of the fire at any given time. Our prototype cost approximately 105 Canadian dollars, but will be retailed for around $60 in order for the production, research, and improver costs to be covered. The Fire Chaser 9001 will be sold to different firefighting units throughout the globe and will be available for mass purchase.